Let's discuss in this video the problem with flat files. In this video, we're going to be looking at the history of how data was processed, and that'll help you to understand why we design databases the way we do. So we've already looked at the old way, the manual way, last week, and the problem was reporting. You just didn't have reports. I could not just run down to the bank and ask for an amortization schedule on my mortgage. Computer can whip that out just like that. But that would have taken a long time to do. Reports just were at a minimum. And so information, which is what reporting is at a minimum back then. However, there were government imposed reports, like tax-related reports that businesses had to generate every quarter. So you'd have a 2-week scramble to get those reports ready of intense work, and even if the manual system was well designed. So what happened when we got computers around was a computer can organize the data a lot quicker than we can. So data processing was the term that we used when computers started working on the data. And initially, the data was just organized very similar to how the manual system was organized. The programming that we had to write had to know exactly how the computer organized that data. Here's an example. Each record is logically on a different line. It looks like a table, but you need to know that, for example, last name always begins at byte 8, and you'd have to define that with every program. And that last name will always take 14 bytes. And if a last name like mine is less than 14 bytes, you pad it with blanks. And if a last name is greater than 14 bytes, then you just get it cut off. It's called truncated. Yeah, 14 is all you get, so we're going to cut off the end part of your last name. And a worksheet in Excel is similar to a flat file. So you take a look at this. One thing that changed was you wouldn't have a limit with a spreadsheet on how wide your text fields could be. So a last name could become 30 characters if you want. But location mattered. So you had to know the location in the old flat file days. And even when I'm writing a program and I reference Excel, I have to know that company is in column E. What will happen to my program if it is decided that a different field would be inserted here? I will have to rewrite my program because company will bump over to column F, and my program will no longer work. Is there a way that we can maintain data and modify data so we don't have to worry about the location of the data? I don't need to know that it's stored at byte 8 or that it's in column E. And that's what databases do. When we computerized flat files, the good news was that reports could be generated faster than a manual system. Of course, that increased the demand. We want more and more information. So we got more and more data. And that demand for more and more data then caused some problems, because to access the data in the computerized flat files, as I mentioned, you need to know where it is in the file. And this is known as structural dependence. If I'm writing a program that is with flat files, I need to know where the data is at. If the file is modified, someone decides we do have to have first name as 20 bytes instead of 14, everything's shifting over and I have to redefine not one program, but every single program that depended on that data. So let's go back to spreadsheets. Are they better? Okay, the length does not matter, so that is better. Does location matter? Yes, location does matter. As I mentioned, if I write a program that accesses the data in Excel and I say this is in column D, and someone inserts a column so it pulls over to column E, then my program no longer is accessing the correct data. A spreadsheet has structural dependence. I have to know where the location is to write a program. So besides structural dependence issues, let's discuss some other issues you might have with a flat file. But I'm going to change the name of this. Let's call it a list instead. Not a database yet. We'll get to that. We have some data here. With these fields: an employee number, name, title, hire date, set of skills, and when they were acquired. Some issues with this is that, look at name, it's not consistently stored. Here's Brian Oates, but here is Richardson, Amanda. If I were asked to produce a list of employees by last name, first name order, I would have to manually do it. The computer can't do it because of how inconsistent the data is being stored. How about if we needed to count how many employees were certified in basic database manipulation? Now, it's the way this data is stored, it's more than just taking a look into this column, because there's basic data manipulation there. Now, so there's one, but look over here, basic DB manipulation. I think it's probably the same thing, data inconsistency, but you can see it's not going to be a quick thing to get that count. And what happens when an employee gets a fourth or a fifth certification? You just continue to add extra columns, I suppose. But what's this null here? Why is this null? For some reason, whoever did this data entry decided that this person's certification is just going to go down the list. And did they get the master database programming on the same date as the basic web design? It looks like that, I guess. Lots of problems with this. All right, so I'm asked to generate a report that first lists each skill in alphabetical order, and below each skill, let's go ahead and put in the name of the employees that have that skill. Not an easy thing to do with this list, but let's look at this next set of data. This may look a little odd, but that one list now is divided into 3 tables in a database, and each separate theme becomes a different table. So we have a table of employees, we have a table of all the possible skills, and then we have a table that relates employee to a skill, which is called certified. Let's take a look at how this fixes some of the issues shown on the previous slide. First of all, if I were asked for a list of employees, last name, first name order, notice now in a database that the fields are separated, last name and first name. When you create fields, you want fields to be atomic, the smallest piece of information that still makes sense. First name and last name instead of name is how I'm going to store this. Real easy to get that list. How about the problem with basic database manipulation? Because skill is storing that record and we only store it once. Here it is, record 210, and it's addressed as basic database manipulation. There's no basic DB manipulation. And the way this is going to work is certified is known as a junction or linking table. And it is going to link employee to the skill. We're going to assign a primary key to employee called employee ID and a primary key to skill called skill ID. And that primary key comes over to employee and the skill ID comes over. And that extra field, the certified date, is also added to this certified table. Any information that you had in the other table is here. So I can take a look at employee 2, 3, 4, 5. He's got 3 certifications. That's Brian. And his certifications are 100, 110, 180. Basic Database Management, Basic Web Design, and Advanced Database Management System. And here are the dates that Brian obtained those certifications. So this is how a database works. And remember, I had mentioned that what if I was asked to generate a report listing all skills, and below those skills, please list all employees with those skills in last name, first name order. Here I wrote some SQL to do just that. This is going to come in the second half of the course, so no worries about what this means yet. Within a few lines code, I was able to generate that list. No need to manually change anything. Let's discuss this concept of anomalies, because when you use a list that isn't correctly formatted, you get an anomaly. The word anomaly just means an abnormality. Something's not quite right here. And a list with one theme does not have anomalies. So here I have a list. The only theme is student. Because the fields are atomic, I can easily sort by last name. I could grow this for thousands of records, I do not see that there's a problem with this list. But let's say now I need to know what advisor a student has. So the person creating this list decides to have the advisor's email, but also wants to know their last name. This way we can say, well, Matthew, your advisor is Miss Baker, and here's her email address. This is going to introduce what's known as some redundancy, because you'll notice the same data occurs in more than one place. So redundancy can cause anomalies. Down here, we're going to look at some of the anomalies just adding those 2 extra columns can cause. First of all, let's say Chip Marino is no longer a student, and I delete row 7. If row 7 is not here, can you tell me what advisor Ken Tran's email is? No, because I just deleted that out. That's the only location I had his email address. Changed row, inconsistent data. Suppose I'm now told that Miss Susan Tang has married, and there's 2 Tangs. And whoever's keeping it, let's say there's hundreds of rows with Tang. Let's say who's ever maintaining this has to change the Tang here and the Tang here, and all 100 rows has to go through. Let's say they miss a few rows. Guess what that introduces? Data inconsistency. Sometimes we have Tang and sometimes we have her new name, Schmidt. Finally, let's say we get a new advisor who doesn't have any students. They're just starting, but you want to store the fact that you have the advisor's last name and their email address. You need to store that somewhere. Well, here we got, well, let's add this new row, but there's no students yet. So Green's name is here, Green's email is here, but no data is here because he doesn't have any students. That's called null data, null, no data. And it's not a good thing. We don't want null data in a database. And storing this correctly will eliminate that. So how do you fix that? Well, you're going to create a different table for each theme. So you need to identify what themes there are. In this case, there's 2 themes. We have the student theme and the advisor theme. So we're going to create a table called student and another table called advisor. Then we're going to identify a primary key for each of the tables. And hint, you might decide to do an ID field. Just create a student ID field, for example. Move the set of data with the correct fields into the proper table. But here's the caveat. You need to have a way to relate this student has this advisor. So you have to decide on what's going to be the foreign key field and place that where it belongs. This will be the only thing that seems redundant. So here we have the advisor table, and let's discuss the issue with Susan Tang getting married, and her last name's now Schmidt. There's one place to change it. That's it. The person comes in, updates that one record. We're done. It's not redundantly stored in many locations. In review, having just said that we only need to change her name once, except for this design, which uses the last name for the advisor as the foreign key. And that means the foreign key for the advisor in the student table must be updated, making multiple changes again to Susan's last name. I would make an advisor ID as the primary key, and then this would not happen. I need to email Matthew Andrews' advisor. So we come to his record, we find Baker, then we come over to Baker, and there's Linda Baker's email address. All the data is still there, but we're going to get rid of our anomalies. Let's look at that insert anomaly. In this slide, remember we were trying to add George Green, and we got this null data. Let's look at this now. If we add George Green, I'm not missing. Green is not here. Doesn't have to have a student. I can still add George Green's name without adding null data to the student fields. Now let's say Chip Marino is no longer with us. We delete Chip's record. Does it delete the Tran data? No. The data about Ken Tran is still here. So those anomalies are fixed by properly separating those themes. And here we have added even another theme. So it continues. A database has many themes, okay? So here we have a department data, and we want to now know that an advisor is for a certain department. Instead of just putting the department name here along with the department phone and who's the administrator, etc., which could cause data inconsistency and other anomalies. Department table is created with the data needed about departments. The department name is the primary key field. I need to know what department an advisor advises for. It becomes the foreign key over there. And you will see later when we're actually doing database design, we'll call theme an entity. So in summary, data redundancy leads to poor data security because you got data all over the place, and that increases the chance of unauthorized access. Data inconsistency, different data, just keyed in differently all over the place again. Data entry errors, the more you got to put in the same phone number again and again and again, the more likely you are to make an error. Data integrity issues, so problems with data accuracy, that's what data integrity is. And we saw that there were update anomalies, insertion anomalies, and deletion anomalies. And you'll do a few exercises, and you will be given a few exercises where you will be taking data that's in a list and separating it into multiple entities.